In this video, we're going to use test-driven design and behavior-driven design to start to implement our service layer. So let's take a look at what we have so far. We have a project right now, and we have a single DTO, and then we have a couple of controller classes. If we compare that to our class diagram, we see that we have a specimen DTO and then a controller. There's a lot more that we need to build out here. And part of that is this service layer. So you see we have the UI layer, which includes the controller, the service layer, and then the DAO. Let's remember what each of these do. The UI is essentially responding to events that a user initiates, things like button clicks or submitting a form, something like that. The service layer is business logic, and then the DAO layer is actually talking to the database. Now, typically when I explain that in a class, the UI makes sense, the DAO makes sense, but there's a lot of confusion around the service layer and what it does, and what is business logic. Well, the best case I can think for business logic is promotions. Think about a buy one, get one free offer at a retailer. Something like buy one, get one free limit 4. Well, what if the customer buys 3 items, an odd number? Which one does the customer get free? What if it's limit 4 and the customer buys 7 items? Then which of those do you pair up as a buy one, get one free, and which ones does the customer get? So this is the thinking that's business logic, and that's what goes into a service layer. So how are we going to start our service layer? Well, we kind of have an idea of some classes and some interfaces that we want. But in a true test-driven design approach, we're going to start with our requirements document and start with these examples that I've elaborated. From here, we can very easily turn these into behavior-driven design tests using the Gherkins or given when then syntax. When we start writing our tests, we can start formulating what the service layer is going to look like because we need to think, well, okay, if these are my requirements, what will the service need to do to fulfill these requirements for me? So the sequence of steps is we build the test before we write the code that will fulfill the test. So we know that the test is going to fail or probably not even compile when we first write it. But then that will help us think about what we need to do to make it compile number 1. And number 2, once it's compiled, then we can think about how we can get the test to pass. And once the test pass, then we're in good shape. Now, one trick is that we are in the early stages of development now, so we don't have a DAO. So we can't really do everything that a specimen service could do. But that's okay. We can hard code some predictable responses into a stub, which you see here is specimen service stub. This works extraordinarily well if the stub with the hard-coded responses and the eventual implementation that we'll write later, if they both implement the same interface, because then we can use that interface as a variable type. And the object that we store in that variable can either be the hard-coded stub or the actual implementation. Or what's most likely to happen is we start it with the stub, then that gives us time to work on the implementation, and then when the implementation is finished, we remove the stub and replace it with the implementation. So let's get started. First requirement, as a homeowner, I want to be able to catalog my specimens so that I will remember what I planted. So I elaborated several examples here, which is the idea. Each requirement should have numerous examples. Now, we don't need to implement every example in this video. We can just pick a few and implement them. Let's start with this one. Given specimen data are available and specimen 83 is eastern redbud, when the user or service searches for the specimen with ID 83, then my plant diary will return exactly 1 specimen for record eastern redbud. We're indicating that this 83 is a unique identifier. So, if we take a look in our project, they were kind enough to give us an example test, and we can simply build on top of that. You'll see a few annotations in here that we'll need to use. For example, @SpringBootTest indicates that this is a test that's run with Spring Boot, so we can get access to things like auto-wired and component and the other Spring type annotations. Also, @test indicates that this is a unit test which can be run, and you notice in IntelliJ they give us a little green arrow by each of these @test annotated methods, and also a double arrow by the whole class. What that means is that I can press play on this one method, and it will run only this test. Now it's going to build and it's going to run, but this test isn't actually doing anything, so I'm not anticipating any results. if I pressed the double arrow up here, it would run every single test in this file. Right now there's only one test, but if I had multiple test methods, it would run each of them. Notice as it's running, it started up Spring Boot, and then it went through and it said all tests pass. Well, there's nothing in the test, so it passes because there's nothing that causes it to fail. Let's go ahead and create some new tests for our new behavior, and for that I'm going to create a new branch as well. So we'll say initial TDD, something like that, and then create. Creating a new branch is essentially taking a picture of this source code where it is at this point in time. And then we can start working in our separate branch without affecting master. So let's start with our first test. We'll typically name the test after the method that it is testing and then the behavior that we expect. So we'll start with this one where we're looking at specimen number 83. Okay, so we'll say void. Well, gosh, what method are we testing? Well, remember we're writing tests around our service classes now, and so this is going to be the specimen service class. We might as well have a method on there, something like fetch specimen by ID, and then we'll do an underscore and then say returns redbud for ID 83, and that adequately describes our test. And then we have open curly and close curly. Now, we want this to run as a test, so we're going to put an @test annotation on top of it, just as the test up above has. Now, we need to make the given when then statements. So this is fairly straightforward as well. Given, when, and then are going to be each independent methods, and we want to name it something that reflects what we see here. One trick that I've found in most IDEs is it helps to start from the bottom and work up, because it can automatically create methods for you, but it does it in the order that you create them, if that makes sense. So if you start from the bottom and work up, it actually creates them in an order that makes a bit more sense when it's all done. So let's start with the then. We'll return exactly one specimen for Eastern Redbud. So let's just kind of paraphrase that one a little bit and says returns, start with a verb. So then return one Eastern Redbud specimen for ID 83. You see, that's a very long-winded method name, right? But that's common in unit tests because if it fails, we want to know what step it failed on. And many times when a method is more of a sentence than a word, that helps us identify where that test failed. Okay, now it's redlining, and naturally I want to fix a redline. Well, it's redlining because I'm calling a method that does not yet exist. But no problem, in IntelliJ, I just hold Alt and press Enter, and it will go ahead and create the method for me. Okay, let's go back and look at another one. So when the user or service searches for the specimen with ID 83. Here again, we don't have to exactly mirror those words there, but let's paraphrase it so that we can kind of match it up a little bit. So when the user searches for specimen with ID 83, so when specimen with ID 83, let's say when search specimen with ID 83. Okay, terminate with a semicolon. We know the trick here. If it's redlining, Alt-Enter will create that method. Now, do you notice where it created the method? It put the when method above the then method that we just created. And that's why I say it's sometimes good to start at the bottom and work up, because each new method appears right here, right after the method we're creating. So if we start from the bottom and work up, they end up actually getting created in roughly the correct order. Next, given specimen data are available and specimen 83 is Eastern Redbud. This one I could probably cut into two different givens, or maybe even move the specimen 83 as Eastern Redbud. I could maybe make that a when. That might make a bit more sense. Either way, there's not a whole lot we can do for this one anyway. Let's go ahead and stub out the method, and then we'll think about it as we're putting it together. So, given specimen data are available, and that's fine. We'll leave it at that. I'm not going to worry about the 83 and create method. There we go. Okay, so now we have our test, and if I were to run the test right now, it would pass because we're not actually testing anything. Let's think about our methods that we've made here. Zoom out so we can look at it in high definition. So I've zoomed up a bit, make it a little easier to see on the video. And let's see, given specimen data are available. Okay, since we're using a hard-coded return here, not a whole lot we need to do for that one. But now let's take a look at the next one. When we search a specimen with ID 83. Now we can work with this. And again, let's remember we're testing this service layer here, which does not yet exist. But we have some clues from our design document. We know we're going to have an interface called iSpecimenService. So let's go ahead and start with that. Up towards the top of this file, we'll make a new variable, iSpecimenService, and we'll call it SpecimenService. Now, because this is Spring, we can simply add an auto-wired annotation on top. And remember, we have the Spring Boot test annotation, so it knows what that's all about. Now, this does not compile. It says, no beans of iSpecimenService type found. Well, that's not a big surprise, because guess what? We don't have one. But there again, this is test-driven design, so we're writing the test before we write the code. Nonetheless, by putting this declaration and annotation here, I can at least now start to access specimen service. We'll say specimen service.fetch by ID, and we'll pass in the number 83. And we anticipate that that is going to return a specimen. We'll make a new private variable. We'll go ahead and make this one. We can make this private as well. Make a new private variable up on top. Specimen. Now you notice that I already do have the specimen DTO class from a previous video that I made. That's not always going to be a given. So if it's not there, it would redline, it would give me an issue. Right now it's redlining, but this is actually a fixable redline because IntelliJ says, hey, I know where this specimen is. I think it's in this package com.myplantdiary.enterprise.dto. Is this the one you want? And I say, yeah, that's the one I want. And then it's going to add an import statement for me. There we go, importing our specimen. Okay, so what I can do then, you see I've declared an attribute, something at the class level that describes this specimen. Now what I can do is I can assign it down below. Specimen equals SpecimenService.fetchById. Now, once again, the fetchById is redlining because there is no such method fetchById, but guess what? That's because there is no such interface, iSpecimenService. But look what we know now. Just from this line number 30, we know that our specimen service interface should have a fetchById method. That fetchById method should accept a number and should return a specimen. So all of this service level stuff we're figuring out just by writing the unit test. And indeed, if we go back to our controller, we know that we have a get endpoint for specimen with a specific ID. So now we see how our controller in the UI layer can call this specimen service that we have not yet created. Finally, then return one Eastern Redbud specimen for ID 83. Okay, so here we can say specimen.get, we could say get description dot equals, and then we could say Eastern Redbud, something like that. And what we'll need to do is actually wrap this in an assert. So you can probably read this line and understand what's going on. Let's get the description and make sure that it contains the word Eastern Redbud. But let's actually remove this part here and change it around a little bit. We're going to say string description equals specimen.getDescription. And then we're going to use a JUnit assert. An assert is something in JUnit where we say, I was expecting this and I actually received this. So one of the most common is assert equals or assert not equals, where you simply say, okay, I got X, I expected Y. And if you say assert equals, that will return true if they are equal. It will return false if they are not equal, or in other words, it will fail the test if they're not equal. Where assert not equals is the opposite of that. You're expecting these two things to be different. Assert false and assert true is similar to assert equals and assert not equals, but in assert false and assert true, we're simply asserting against a Boolean, where in assert equals and assert not equals, we are asserting against a number, a character, a string, something like that. You can see a few others here. Assert null, make sure that an object is actually null or a variable is null. It's not been assigned an object, for instance. Assert that is a complicated one, a more complicated one that uses some things called like a Hamcrest style asserts and a matcher object. That's good if you need to do a really complicated test, which is a good idea to make sure you have thorough coverage. And then fail. Fail forces a test to fail, and why would you want to do that? Well, maybe your test has reached a line of code you did not anticipate that it would reach, so you want to fail the test intentionally. Now we have enough information to complete this test because we have the description that we've received from the specimen that we retrieved in the when part. We simply need to validate it. So let's start with an assert equals. And we'll typically put the expected value first, so Eastern Redbud, and then the actual value next, which is what we retrieved on line 34, which is what was retrieved on line 30. So we'll simply say description. Now something funny here, you see assert equals, it looks like a local method, but it's not. It's actually what's called a static import. In other words, it's a static method in another class, but we can refer to it as if it's a method in our class, provided that we import it correctly. ID is going to help me out here, so Alt-Enter, and import static method is an option. And if we take a look up at the top, you notice it resolved itself there. Looking a little better there, but our test is absolutely going to fail right now because we're still broken. We still don't have an iSpecimen service, and we still don't have a fetch by ID. But here again, this is test-driven design. So we write the test first, and then that helps us figure out what our next steps are going to be for doing the implementation. So let's start with iSpecimen service, and we know that should be in a service package as it's described on this UML, so we can start with that. New package, com.myplantdiary.enterprise.service. And then under here, new, and we'll say Java class. We're actually going to change that to interface and then say iSpecimen, and go ahead and add that to Git. Okay, now we're getting a little bit closer on our application test. So let's take a look. Ooh, we have something here we didn't have before. Now it gives us an underline and it says, I think I know what interface this should be. So I hit Alt and press Enter, and we're good with the interface. At least the import. We still have an issue with the implementation though, because this is a variable, specimen service, and we have to put an object into that variable. An object can only come from a class. An object cannot come from an interface. So still one more thing we have to tidy up here, which we'll do in a moment. But first, let's go back down and take a look at this method which does not yet exist on our interface. So I Alt-Enter and take a look at this. This is a really handy thing with IDEs. It says, I don't know what method this is, but I know it's on specimen service, and I now know that specimen service is represented by this interface iSpecimen service. Would you like me to create a method with this name in specimen service? And I go ahead and click yes, and take a look. It gives me a stub of a method. Now I'm going to give it a more descriptive name here. We'll say int ID, not that that's terribly much more descriptive than I, but nonetheless. For this we'll say fetch a specimen with a given ID. Okay, a unique identifier for a specimen, the matching specimen, or null if no matches found. And save. And back to our enterprise application test, you see now that red line's gone. Okay, we still need to handle this one though. Could not auto wire. So one thing to note is that auto wire is a companion to another annotation called component. These two go together. Auto wire says, I'm a variable declaration. Go out and find a class that's annotated with @component, where we could take that class, create an object out of it, and we could store that object in this variable. In other words, we have an interface, we do not yet have a class that implements that interface. Given our class diagram, we could plug in a stub, or we could plug in an actual implementation. We know this early out from the project. We don't know what that implementation is going to look like yet, because we don't know enough about the technology stack down there. So let's start with specimen service stub. So go back to our service package, choose new, Java class. This time we'll choose class and we'll say specimen service stub. Just like so. Go ahead and add. And then we'll say implements iSpecimen service. Okay, as soon as I give it that implement line, you notice it gives me a red line. Let's Alt-Enter and see what it says. Well, it says implement methods. You see, an interface is a contract. So if we're implementing an interface, we are under contract to implement all of the methods for that interface. There's one little exception where we don't have to if we're an abstract class, but let's not confuse things with that just yet. So go ahead and choose implement methods, and boy, that looks familiar, fetch by ID. Oh, cool, see that? So you notice that we started with our test. From our test, we went to design the interface. From the interface, that led to the design of our stub, and therefore we have true test-driven design here. We go back to our test, and it still doesn't like the case of specimen service because it still could not auto-wire. Well, the auto-wired annotation is half of the agreement, but the other half of the agreement is anything that you want to be a candidate for auto-wiring, you have to put the @component annotation on top, and notice it was kind enough to do an import for me there. And then it says, okay, I can be auto-wired either into a variable that's the same type as myself, or anything I superclass, or a variable that is the interface type that I implement. So now we have a qualified auto-wire. Let's go back and take a look, and holy smokes, take a look. Our test now at least compiles. So I can run and see what results we get. Well, this time the test ran and it failed, and that's not an entire surprise given that we are using test-driven design. Let's see where it failed to make sure it's a place where we thought. Okay, then return 1 eastern redbud. Well, let's see. It says specimens is null. Well, we're assigning specimen here on line 33, and we're assigning that to the return statement of fetch by ID. Okay, so this is our interface. If we go to the stub, well, gosh, look what we're doing. It's returning null. Now, remember the stub is just a hard-coded representation of what the actual implementation will make. We can find those implementation details very easily because they're right here in our given one then. So specimen data are available, and specimen 83 is eastern redbud. Okay, easy enough. So that's the requirements for this method at this point. So let's start by saying specimen. We'll just make a new specimen. Specimen equals new specimen. Okay. And then specimen dot set description, eastern redbud. And then return specimen. We could possibly, tell you what, actually, well, let me do one more. Let me do specimen, because we did say it was going to have a specimen ID of 83. Right now, I've only given it 2 attributes. I could give values to more attributes, but the reality is the test script doesn't tell me to. So I'm going to go ahead and keep it exactly as the test script says. Now, let's go ahead and run one more time. And this time, what do we get? We get a passing test. And that's fairly straightforward because we wrote the test to pass. But nonetheless, you see how far we've gotten here now. We've gotten to our interface, our methods, and we've started a stub. As we continue to work through each of these examples, we're going to end up with a very robust specimen service, iSpecimen service, and stub, and that is what will help us to work out not only the rest of this box, but specifically, it helps us think a little bit about this implementation. So I hope this video has been helpful, and I look forward to reading your comments. Thank you.